All right. Hello, everyone. Welcome to our space science class today. As you can tell, we're going to be talking about space. It's hard for me to tell right now just where the planet is behind me. We talked on Tuesday about comets and asteroids and learned more about those. Today, we're going to learn about what does it take to live in space. Human bodies are not designed to live in space. Space is not designed to support human life. So there's some challenges. But first, very exciting news at something like 4:30 a.m. this morning. I don't know, I wasn't awake. The Perseverance rover launched from Cape Canaveral, Florida for Mars on an Atlas V rocket. And if you were in the classes last week, we looked at a tour of the rocket factory where they make the Atlas V rocket. And we saw some pictures of them making the exact rocket that just launched this morning, a few hours ago, about 7:30 a.m. Eastern time, 4:30 a.m. Pacific. Launch went flawlessly. The spacecraft is on a good trajectory. It is heading to Mars. It will arrive there in February. Okay, popping into the Q&A section. Hello to everyone who is saying good morning. Hello, hello, hello. Gerard is asking, is it possible to bring Benjamin to this class? You know, judging on Benjamin's luck of avoiding injury, I think sending him to space would be a very entertaining idea. You know what? I'll bring Benjamin for the next space science class. So tune in next Tuesday to see what happens to Benjamin. Okay. Ian is saying the Earth used to be a wasteland full of lava and volcanoes. Yeah. In the early days of Earth is about 4.5 billion years old. And in the early days, probably the first billion years or so, totally guessing on that one, it would have been very hot, very, very hot, and it would have taken a lot of time for it to cool down. The early solar system was hot. All this stuff was coming together, combining, crashing into each other, generates a lot of heat. I'm glad that it has cooled down and that we are now at a nice, comfortable temperature as a planet, nice and stable. Okay, let's learn about living in space. What does it take to live in space? So I'm going to concentrate on what is it taking right now to live on the International Space Station. This is not the only space station that exists. It's not the only space station that has existed. It went into full operation, you could call it full operation, in October of 2000. Starting October 2000 until now, there has always been at least one person on board the International Space Station. So for the last 19, 20 years, not every human is on Earth. We are a space traveling civilization now, even if we're just a couple of 100 miles up. But the United States had some space stations before this one. We had Skylab and a few others. The Russians had a lot of space stations, a number of space stations. And I was reading a book recently that was talking about the space race and what it took for America to make the achievements that it did in space, and Russia. Russia, throughout the 70s and 80s, they were doing space stations. They had a space station called Mir. They had several other space stations, and they learned a lot about how to send humans up safely, how to have them live in space, how to survive, what it takes to keep them alive and safe and happy. Just living isn't enough sometimes. You need to be satisfied. You need to be happy. You need to be comfortable, at least to some degree. So when the United States had this idea for, hey, let's make a big giant space station, we'll call it Space Station Freedom. And NASA was telling the government, like, hey, okay, but we need some help. It's going to take a lot of money. It's going to take a lot of expertise and knowledge and know-how. And the United States didn't have all of that. Russia had the scientists that had the experience and people surviving in space. So cooperation, everyone brought what they knew. Everyone brought some money. Everyone pitched in and built this together. Okie dokie. And we have a mutiny in the Q&A section of people demanding Benjamin. All right, well, I can't go and get him right now, but I promise you, don't worry, I promise you we are going to have Benjamin definitely in the class on Monday, covering first aid and emergencies, and I will bring him for space science next week. Milo, no, we are not going to talk about living on Mars specifically. We're going to talk about living in orbit around Earth, but everything that we're talking about here could definitely be translated to living on Mars or living on the moon. You know, how to have oxygen is the same no matter where you go. All right. Good, good, good. All right, one last question and then we'll carry on. Karina's asking, is that a home for the astronauts? Yes, 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 yes. When astronauts are in space right now, they're either living on board the spacecraft that they launched on, which is not gonna be a ton of space. Let me see if there's one. On this picture that we're looking at, it's kind of hard to see the spacecraft. They're all docked on the other side. It's a little bit harder to see. But while they're on the International Space Station, there's plenty of space to live and to work and to do experiments. Oh, there we go. There's a spacecraft right there. So that capsule there is enough for 3 people to live in for a few days. It's gonna be tight. You gotta be really good friends. You gotta get along with people. Okay, so the first part about living in space that we're gonna talk about are life support systems, systems that support life. Or just life support. You might have heard this in movies, you might have heard this in TV shows like, oh, the life support is broken, we need to fix it so that we don't run out of oxygen or something like that. But that is one broad topic that covers a number of different individual parts. So the first thing is oxygen. We need oxygen to breathe, otherwise we die. So that's necessary for supporting life. Don't worry about paying too much attention to what's happening on the screen here. I put this on here as an example to show you can take water, which is composed of H2O. You've got 2 hydrogen and an oxygen. So it means if you have water, you have oxygen, which is great. You can do this process that's called electrolysis. And you take water and you put a couple of electric things in it, you run some electricity through it, and it separates the hydrogen from the oxygen. So you have 2 gases. You have hydrogen gas, which has its own uses. They can use that for stuff. And then you have oxygen that you can breathe and use for stuff. Oh, someone asked a very good question. Yes, these are solar panels up here, all this stuff. Solar panels to generate electricity for the space station. You can see some of them are tilted. The solar panels can move, they angle so that they are getting the most amount of sunshine as they can. And they're constantly moving a bit because the space station orbits the Earth every 90 minutes. They have sunset, 45 minutes later they have sunrise, 45 minutes later they have sunset, 45 minutes later they have sunrise. So they're constantly moving. The sun is constantly changing position very quickly. So they take those panels and they rotate them slowly so that they can get as much sun. All right, so electrolysis, you have water, you zap it with electricity in a very specific way, you can get oxygen from that. Of course, you can just bring tanks of oxygen with you, and they do. It's a great way to just have more, and it's good to have extra. You don't want to run out. Let's say something happens and there's a mistake or an emergency. You don't want to run out of oxygen. You want to have a lot of extra oxygen with you. So they just bring tanks and tanks of oxygen. They might not look like this. They might be bigger, but you can just bring it with you. There's also something called an oxygen candle, which is a little bit little bit misleading. It's not a candle like you would have on a birthday cake. They call it a chemical oxygen generator. You have that case there, and inside the case, you have solid chemicals. And what happens, there's a little spark, which is why they call it a candle. There's a spark, and it starts this reaction where the two solid chemicals combine together in a chemical reaction, and that generates oxygen. This is used, now, I actually don't know if they have these on the International Space Station. I don't know if they do. They might. They definitely had them on earlier space missions, especially Russian space missions, because it is a great emergency supply. If something goes wrong, there's an emergency, you need oxygen right now, and grab an oxygen candle, pop that, let it start burning. It's burning in a very specific way that doesn't blow up or burn down your spaceship. And you've got oxygen. This is also used on Earth sometimes as an emergency supply. Let's say you have a bunch of miners and they're down in the Earth, working on mining gold or coal or salt or something like that. And accidents can happen. There can be a cave-in and they can be trapped there. And you don't want to run out of oxygen if you're trapped underground. And they'll have these oxygen candles with them to generate oxygen if there's an emergency. So several different ways to have oxygen with you. But the best thing, let's see. Okay, yeah, good. There we go. Another thing that you can do is you can scrub the carbon dioxide out of the air. So as we breathe, we're taking in oxygen, and the body's doing all its stuff, and it's taking the oxygen and using it and getting rid of carbon dioxide. We need to breathe in oxygen. We need to breathe out carbon dioxide. Carbon dioxide is poisonous to humans, and too much of it is bad. So there's these things, CO2 scrubbers. Carbon dioxide is CO2, carbon, and then two oxygens together. You can scrub it out of the air. Like when you're doing dishes and there's grease on your dishes and you grab a brush and you scrub it. You're scrubbing the carbon dioxide out of the air. This picture is not from space, that's from a fish tank. Fish also use carbon, in your fish tank, in your aquarium that you might have, you are scrubbing the carbon dioxide out of the water because fish need to bring in oxygen and get rid of carbon dioxide. They're the same as us. They just breathe water and we breathe air. They breathe liquid, we breathe gas. Hey, all right, you guys are asking great questions. I'm going to back up a little bit because we have some really good oxygen questions. All right, so how do you get that much water? You have to launch it into space, and that is difficult. We're going to talk a little bit about water later on. I hope I'm saying your name correctly, Rayanj. So we're going to talk about water and how to make the best use of water up in space. Isis asks, how do you put oxygen in a tank? There's special machines that take oxygen and pump it into the tank at super high pressures. These can be very dangerous if they're punctured, if they're poked, if they're crushed or something like that. You might have seen movies where, someone shoots a tank of gas and the thing just like explodes. That's because there's a lot of gas put in there, super, 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 super dense. Kind of like a tire. You can pump more air into the tire on your bike or on a car than there is normally in the atmosphere. All right. Tanisha says, this is kind of like a science lesson. I'm not saying that it's not about space. Yes, this is science. Haha. This is space science. If you're in a class with me, you're probably going to be learning about some science. But that's okay. If you are playing catch with your friend. You have a baseball and you're throwing that ball back and forth. Guess what? You're studying science, physics especially. You might not know it, but the calculations, the math that you are doing in your head automatically without even thinking about it to figure out how do I take this water bottle and, flip it so that it lands, perfectly, right? If you've ever done a bottle flip, you are doing a science experiment. You are doing a physics experiment. That's super cool. I had a student tell me one time that they are not good at math or that they can't do hard math. And I told them, no, sorry, you're wrong. I was very nice. I told them that they were wrong. Because if you've ever taken 2 cookies and offered them to a young child and said, take whichever cookie you want, you will see them. They're doing the math in their head, trying to figure out which cookie is bigger, or which piece of cake has more frosting on it, or which cookie has more chocolate chips in it. And they're doing, you watch their face. You can see the math happening. You don't think of it as that, but it's what's happening. Not on paper with numbers, but just from their understanding of the universe. Everyone is very capable of doing advanced science, advanced math. You just don't think about it sometimes. That's really cool. I'm rambling. I'm talking a lot. Tanisha asks, how long can people live in space? The longest someone has been in space was a bit over a year. And this was a specific experiment that was done to test certain things. They had ideas about how to make it more comfortable for someone to live in space, how to keep them healthy and safe. And they had to test those things. And we test them very close to the Earth. Send someone up to the International Space Station. They're very close. If something goes wrong, they can hop in one of the spacecraft and be back to Earth in just a couple of days. If you're on Mars and something goes wrong, at best, it's a 9-month journey back home. So we want to test all these things close to home, where support and extra resources are quickly available. All right. So carbon dioxide scrubbers, in addition to adding more oxygen into the air that they're breathing on the space station, they also have these scrubbers, these CO2 scrubbers that take the carbon dioxide out. Water, you need water. I need water. I'm going to take a sip of water real quick. On Earth, it's very easy to get water. You can turn on the faucet, and get it. You can go to the store and buy it. You can put out a bucket and catch the rain. You can go down to the river or creek and scoop up water and filter it and drink that. It's hard in space because there's no water. You have to bring it with you. So they will launch jugs of water, tons of water, and take it up to the International Space Station. It's not cheap to launch anything to space. In some of our earlier classes, we've compared different rockets and how much it costs for each rocket to launch. And the early space shuttles, that very first space shuttle mission, it cost $25,000 per pound of something to get it up into space. The rockets today, the cost is coming way, way down. Now it's only $1,000 per pound to put something in space. Much cheaper, right? You have, my laptop is maybe £1. Great, it would cost $1,000 to get it into space. So it's still very expensive, but as rocket technology continues to develop, as we come up with better ways to build them, more efficient ways to do stuff, the cost continues to get lower and lower. One of the big goals in space engineering, rocket engineering right now, is to get that cost down to like $100 per pound to get something into space. That's very difficult to do. It's a lot of really smart people working on that. Isis is asking which of those methods creates the most oxygen. I don't know if there's one answer for that. It depends on how much you bring with you. I don't know how to answer that question very well. Yeah, I'm sorry. All right. Good. So water, you got to bring it all with you. It's kind of expensive. And we're going to talk about how to reuse it, to recycle water, so you're not constantly having to send a bunch of tanks of water up. In space, there is, on the International Space Station, there's no gravity. The gravity there is such that you just float around. And if I took this bottle of water and I opened it and I just let this sit there on the space station, the water would eventually drip out of it. It would float away. It would, get on my clothes and get me wet, or get in my hair, or it would, float over and get onto my laptop and break the laptop. You don't want stuff just floating around. So all the water that the astronauts drink, they're in these pouches, so the water doesn't go floating away. And the straws are designed so that it only lets stuff out when you are sucking on the straw. The rest of the time, the straw seals it so that it doesn't float out. Water, tea, coffee, orange juice, any liquid that they're going to be using are going to be in some kind of pouch to keep it from floating away. Now, again, you want to recycle. So this is a big fancy machine. This is the Water Recovery System, or WRS. And what this does is all the water that's being used on the space station, it all gets sent back to this thing and recycled. So when you sweat and your sweat evaporates and goes into the air, or when you breathe in and out, you're not just exhaling carbon dioxide and other stuff. There's also water. Water comes out in your exhalation. If you go up to a piece of glass and you breathe on it, there's a mist, there's a fog that forms. There's water in your breath. Also from your urine, when you go to the bathroom, all of that water gets sent to the water recycler. I think you have probably figured out where this is going. All of it is recycled, it's cleaned. They take just the water molecules and they separate them out from everything else that might be in there. And what comes out, the other end of this water recycler is pure, perfectly filtered water, which you can drink. You can use it for bathing, for washing. You can use it for, cleaning things. So what they're drinking there might be recycled water, and it can be recycled over and over and over again. They're able to reuse, I think, 99% of the water up there. So they don't have to send a lot of water with every single mission, every single, cargo resupply that goes up. They only need to bring a bit of water because they're not losing very much. That doesn't sound... Yeah, okay, so there's people in here saying it's disgusting or that's gross. Yeah, hey, it's what it is. But it's also what's necessary. Urine is water with a bunch of stuff that your body was trying to get rid of. So you can put that into a recycler and it takes all that stuff out, brings out just the water, just the H2O molecules, and you've got super clean water. And I think it's easier if you don't think about it. I've heard interviews with astronauts where they say, yeah, we just try not to think about it. It tastes great. It's perfectly clean water. Tastes like water. They have confidence in the machines that are on the space station, confidence in the engineering and the people who designed and built these devices. Okay. Isaiah is asking, how do they shower in space? So showering in space isn't super possible because that water would go flying everywhere. It would spread around. It would create quite a mess. The way they bathe in space is with sponge baths. Basically, they have sponges or washcloths, which they'll get wet with water and they'll rub their bodies down. But astronauts do say that when they newly arrive to the space station, at first it smells a little interesting to them because you're not able to get that deep clean like you could with a full bath or a full shower. But after a little bit of time, they get used to it. They keep themselves clean. You know, these gentlemen do not look dirty. But you would notice a smell when you first go up there, just like if you had to use only sponge baths for the next 6 months, the smell would change. Yeah. All right. Tanisha is asking, how do they go to the bathroom? That's the real question. I have some pictures on that a little bit later. Isaiah is asking, could they have a room that has gravity? There's a few ways of generating gravity, fake gravity in space. There's some science fiction ideas. You could have something that creates like a fake gravity feeling, artificial gravity. We don't have the technology to create those right now. It's purely theoretical. The easiest way to create gravity in space is if you had a spacecraft that was constantly, that had the engine on, and it was constantly thrusting, you would be pushing, you know, let's say engine's here, spacecraft goes up. There we go. Spacecraft is going up. Engine is firing this way. You could stand right here and feel like gravity is this way. You're being pushed up like this. And that would create a feeling of gravity. That would create gravity. Or what you can do, let's see if I can, yeah, let me grab something really quick here. We have this bandage from our first aid classes. So if I'm just holding it here, it's just dangling, gravity is pulling it down like this. If we were in space, it would just kind of be floating without any real direction. But if you spin something in space, you start going like that. This is not a great demonstration. Start spinning it like that. The outer edge of this cloth is being pushed outward. So you could have a spacecraft that is swinging around, or you could have a long spacecraft that's spinning like this. And on this end, you would have gravity going this way. And on this end, you would have gravity going this way. I don't have a lot of slides on that right now, but we could do some more on that next week, maybe. Okay, Matthew's asking, are you drinking toilet water right now? Nope, I am not, don't worry. Okay. Aubrey asks, what happens if an astronaut throws up in space? This has happened because when you go into a zero gravity situation, it can throw your body off. You can get dizzy. Your body is used to having a down, an up and a down. You have stuff in your stomach that it doesn't come out through your mouth because it's being pulled down by gravity. But if that downward pull isn't there and it's just kind of bouncing around in your stomach, it could kind of start to float up like this. And you could be dizzy from the lack of gravity. If you go on a roller coaster and you go on one of the deep plunges where you can experience zero gravity for a little bit, you might feel nauseous, like you're going to throw up. So astronauts have thrown up. They bring bags so that they can vomit into the bags. Sometimes it happens. You don't want to throw up in your helmet. That's very bad. That would be a big mess. All right. What are we talking about next? We talked about water, how you drink, how they get it up there, how to recycle it. Food, you want food, otherwise you can't eat. So you would not want to have super messy stuff up there, right? I wouldn't want a super, splashy sauce on the meatballs. So we're gonna look at some food that they have up there. All the food that goes up is sealed in these packets like this. It keeps them from floating around. It keeps them, it takes up the least amount of space. And what they're also going to do with many foods is they're gonna take some of the water out of it, because they're gonna have a lot of water on the space station. They use it for drinking. They use it, excuse me. I thought I was going to be able to suppress that sneeze. But you have a lot of water. You can use it for cleaning. It gets recycled. You can turn it into oxygen, and you can add that water to the dried food that you bring up. Here are some real foods that they have brought up. This one says crackers, there's trail mix, beef patties, hamburgers. There's cheese spread in this pouch here. Beef steak, that's a steak in there, look at that. Cashews. Now, I don't know if you can all see this very well, but look, under crackers, below the barcode, it says another word. Does anyone know what that is? What language that is? That's Russian, exactly, Sam. Every astronaut that goes to the space station has to know English, and they have to know Russian. And everything that goes up is, it's printed in English and in Russian. It's a very cooperative thing up there. So, well, I say that, and then this pouch just says orangeade. I don't see Russian on this. I wonder if on the bottom of the packet or on the other side of the packet, if it says orangeade in Russian. I might have just proven myself wrong, but I don't think so. Let's see. Sam says, wait a second, all that's food from 2003. Yeah, it's an older picture, but the same techniques are still used. So I'm sure that this stuff was eaten 15 years ago on the space station. Yep. Good. Oh, look, candy-coated peanuts. M&Ms, basically. Let's look at some more food. This is an older photo here, but you can still see, here's this pouch that looks like maybe a spaghetti sauce. We've got, that might be meatloaf, that looks like rice. I don't know what that is. A sandwich, peanut butter and jelly, I don't know. That looks like a Rice Krispie treat or something like that. Got bread, maybe a stew. That might be peanut butter there. Here's a kind of an expandable jar with some maybe orange juice in it. So, and you can see there's heaters. You can put these cups of stuff in these ports, and it'll heat it up. And yeah, it might still create a little bit of a mess. Some of the stuff might float away, but the interviews that I've listened to from astronauts, they say you get pretty good at playing with your food. Sometimes you'll, like take a little bit of a strawberry and kind of push it, and it'll go floating through space, and you drift over and you grab the strawberry out of the air. Or they'll take some water or orange juice or some kind of liquid and kind of squeeze it out of the pouch, and then you just have this ball of water hanging in the air, and you come up and drink it up. Do I have more food pictures? Hey, okay, so I grew up hearing about astronaut ice cream, and every time I went to a museum or something, there was this astronaut ice cream for sale in the gift shop or something like that. Well, astronauts don't really do astronaut ice cream. It was sent up a couple of times, but it's very crumbly. It was an idea that was being practiced. What if we could take all the moisture out of a thing, send it up, and they could eat that and drink water. It didn't taste as good as they wanted it to. The texture, the astronauts weren't super happy with it. A lot of eating, a lot of the process of eating, the enjoyment is the textures of what you're eating. You have a nice crunchy corn chip, or like the soft chew of a strawberry, or kind of the like popcorn, kind of that crunch and chew. The texture in your mouth is a lot of it. And if you take all that texture away and make it all this kind of like paste that it turns into in your mouth, you don't get as much enjoyment out of it. Yeah, and it's super crumbly. It creates a lot of crumbs, and crumbs are a problem in the International Space Station. You can't have crumbs getting everywhere. On Earth, it's easy. They fall to the table, they fall to the ground, and you wipe them up. There's no falling to the table in space. So it drifts around, it gets into the equipment, and it creates problems. You don't want crumbs. So it was an idea. They didn't end up using it very much, but it sure sells good. And it's a fun snack to have every once in a while. Something that they do use a lot up in the space station are tortillas. Think of how crumbly a tortilla is versus a piece of bread. Not very crumbly. It creates less of a mess. And it's a great way to, here we have that looks like some beans and maybe some salsa and some cheese. That astronaut's going to have a nice, beef and bean taco, beef and bean and cheese taco or burrito. And that food's not going to, you wrap it up and it's not going to go flying around everywhere. It's not going to go drifting off. It's very easy to manage that. So lots of tortillas eaten on the space station. Someone's asking Mexican tortillas. I would call them space tortillas because that sounds cool. Isa says, that cheese looks weird. Yeah, space cheese. It got squeezed out of a tube. So I guess that's just what it is. Look back there, you can see, I didn't even notice this before. You can see food pouches just kind of drifting around over there. They must be in the middle of lunch here. Maybe they squeezed some of the stuff out of this. That looks like maybe it's the bean paste tube or the salsa tube that you would squeeze it out of. And everything's strapped down. You can see there's Velcro. Hey, Velcro is all over the place on the International Space Station, everywhere. So there's these Velcro straps that they can use to strap stuff down, or maybe the backside of that pouch has a Velcro thing that you can stick it to something to keep it from floating away. All right, someone was asking about the bathroom. This looks more like something out of, like, it might be like a torture device or something that an alien would use on a spaceship. This is a human toilet on the space station. You've got these things here. So that after you sit down, you can pull these over and they will keep you there, keep you from floating away, because you don't want to float away while you're using the bathroom. There is a suction that's happening. There's some kind of suction. I don't know if it's a fan or something that's pulling air down into the toilet to make sure that anything that happens, it gets sucked into the toilet and contained instead of floating out. And there's a tube that you can use as well. We're not going to go a lot into that. Oh, look, gloves in case they need to clean it. You can tell that this picture was taken on Earth in gravity, not on the space station, because that glove is being pulled down by gravity. Otherwise, it would just kind of be floating. Ethan is asking, how many square feet is the International Space Station? I don't know off the top of my head. I'm going to cheat. It's not cheating. I am going to elect to do additional independent research. That sounds better. How many square feet on the ISS? 35,000 square feet. Nope, that's not right. Oh, that's how big the solar panels are on the space station. 35,000 square feet. Mhm. Thank you for your patience as I click around for this information. Okay, there's a lot. So we're not going to look at square feet, which would be flat. We're going to look at cubic feet, a cube of space. Square feet is important on Earth because everything goes down. There's a floor, and that floor is what's usable to you in space. Wow, we're almost out of time. I have more slides. I have to speed up. It is 32,333 cubic feet of pressurized space in the space station. That's a lot. Speeding up because James is taking too long. You have to exercise in space. Even if you have to be in really good shape to go to space, physically and mentally. But you have to exercise for about 2 hours, at least 2 hours a day in space, because there's no gravity. Your muscles aren't pushing on very much. You start to lose muscle. You start to lose bone density. So there are springs in here that are pushing the bar down, and the astronaut gets under it and pushes the bar up with his legs and arms and gets some exercise like that. They have treadmills, and you strap yourself into this harness, and you've got these bungee cords here that pull you down. Then you have to push up off of it. It's very interesting. And there's a guy floating sideways in the background because there's no down in space. Sleeping, you don't want to just drift around the space station while you're asleep. You might bump your head into something or get in someone's way. You strap into these sleeping bags, which are attached to the wall or floor or ceiling, whatever big difference. And you can strap your head into to keep your head from bobbing around. That's how they sleep. He's sleeping on the wall because there are no walls. Every surface is a wall. Every surface is a floor. Here's another picture. Here they are, just kind of strapped. And that guy's got a face mask on, so they don't have to turn. It looks like someone zipped all the way up. There's their head. They're in the sleeping bag there. What's happening here also, you don't see it, but there's fans constantly moving the air, because without the air being moved by fans, you would breathe the same space of air over and over again. And you would use all the oxygen from it, and carbon dioxide would go out, and you would suffocate. You could be in a room full of perfectly breathable air, and if it wasn't moving, you would suffocate very quickly because you would use all the oxygen that's close by. So the air always moves. Here's a pair of pants, and you can see there's some lighter blue stripes on them. Those are Velcro. On the legs of their pants and shorts, they will have Velcro so that they can, stick stuff to them and not have them float away. And there's a lot of work that they have to do on the International Space Station. That's the whole point that they're going up. And they use every surface. So you've got laptops over here. You've got all kinds of devices over here. There's more control panels and control surfaces up there and down there. They stick stuff everywhere that they can. There's dozens of experiments happening all at the same time at any moment on the space station. All these look, here's cameras that have been added in here. I guess that's their camera storage. What else is going on here? Here's a joystick to control, I don't know, something. Lots of work, lots of space to do that work. Here's 2 astronauts working on something. I don't know what that is, but it's really cool. And look, there's laptops over here, and there's laptops over here. Notice there's this bar on the ground, and his foot is under the bar. That allows him to keep himself stable, keep himself from floating away or going sideways as he's working on this machine here. He can bend his legs, bend his knees and go lower and not float away. Sometimes they have to do work outside the space station. They're tethered here. There's cables connecting them to the space station, but they got to go outside all the time. You know, every few weeks, there's going to be at least a few missions going outside to repair things, check things out. They just did a series of spacewalks over the last kind of 2 months to replace a bunch of batteries that were out there. Fresh batteries were sent up from Earth. So they took out the old ones, put in the new ones. There's a lot of maintenance, a lot of housework, yard work, just making sure the thing doesn't fall apart around you. There's a guy having a good time. He's out there taking a selfie. You can see he's holding on to, there's handles everywhere. Handle, 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 all over the place. Not only for you to grab onto with your hands, but you can see he's clipped in. There's a clip right there. And usually they have 2 clips. So that even if one breaks or falls off or something, they're still not gonna float away. And you might have to do some gardening. You might have to do some farming. There are experiments happening right now where they are growing plants in space. They had a salad, I forget, last year, the year before, sometime kind of recent, where everything that they ate in that salad was grown on the International Space Station. And I think they've practiced a bit with growing stuff with dirt, but more efficient than that would be to grow it with water, something called aquaponics. And that means growing plants in water, basically. You have the plant here, there's like a barrier, something that the plant can grow through and hold it in place, and there's water under that. And the water has nutrients in it. It has the stuff in the water that the plant needs to grow, that it would get from the soil on Earth. And it can grow. So they knew that it was possible, but then they had to do the work to actually do it, to make sure it works the way that they thought it would. Okay, Alette is asking, what if both clips broke? Both clips while they were out on the spacewalk. Then you're in trouble. But that's why you have 2. The chances of one clip breaking are very, very small. The chances of 2 clips breaking at the same time are almost impossible. Not 100% impossible, but it would take something truly disastrous to make that happen. So, and if that's going to happen, you've got bigger problems too. So 2 clips is enough of a safety net that they're comfortable with that. I am over time. I knew that was going to happen. I started a few minutes late because I was looking for the perfect background. I'll be honest, that's exactly why I started late. I'm like, oh, I don't like that picture. I don't like that one. I know we're a few minutes over here, but I'm going to stick around. Even after, yeah, okay, that's the end of my slides. After I sign off here, after the camera cuts, I'm going to stick around in the Q&A section and ask, if you have any last questions I didn't answer, I'm going to stick around and try to answer them by typing there. Thank you so much for joining me today. I'll see you on Monday, where we're going to be talking about first aid and emergencies. Tuesday and Thursday next week, more space science. Coming up later today, we have computer science at 1:15 Pacific time. All right. Bye, everyone.